Distroless images are designed to contain only the application and its runtime dependencies. Sounds cool, but maybe it's just a buzzword. Let's find out. We will discuss theory and practice. If you are here for some coding, click on the timeline and go to the part you need. The name Distroless suggests that there is no Linux distro in the image. This is not exactly so. So-called distroless images do contain a Linux distro, but a very stripped-down one. There is no package manager, shell, or other typical Linux components. The most minimalistic distroless images contain only the CA certificates, time zone data, password entry, and the TMP directory. Such an image takes up only about 2 megabytes. Well, that sounds clean and minimal. Where's the catch? Statically linked applications may use the image that I told you about, but the application can require a libc, a runtime, or some other components, and so it won't survive in it. Also, debugging and profiling distroless images is a challenge. There is no shell, no required utilities, a perfect Ding an sich selbst. You know what else is a challenge? To configure a distroless image if your application doesn't fit. To do that, you need to dig down and acquire new skills, like Bazel or Kung Fu. Scratch, Distroless, Slim images, minimalistic Linux distros, they all promise small container images with enhanced security. But what's the difference between them? The core philosophy is the same: less megabytes, less packages, and less vulnerabilities. The difference is in the degree of cleanup. Scratch images don't contain any Linux distro at all. Nada, nichts. Only your statically linked application that became enlightened and doesn't require anything to run. Distroless images contain the remains of the Linux distro, like time zone or certificates. Depending on the type, they may contain a libc or additional packages. Slim images don't contain a package manager. Some of them contain a shell, some of them don't. That depends on the vendor. And finally, there are images based on minimalistic Linux distro like Alpine or Alpaquita. These images are really small, about 5 megabytes in size, but they are fully functional. They contain a shell, they contain a package manager in their full version, APK, and also necessary utilities for your application. If you need more packages, you can pull them from the repo. Which choice is the best? Well, actually, there is no competition. Select an image based on your requirements and capabilities. Now that we know what's what, let's open Distroless up and see what's inside. Not all applications can fit into one cookie cutter. So, there are several types of distroless images for various applications. I will discuss distroless images provided by the Google Container Tools, but keep in mind that there are other distroless images provided by other vendors, such as ChainGuard. Static image. It contains CA certificates, time zone data, password entry, and a TMP directory. Base image. It contains the static image plus glibc, libSSL, and OpenSSL. CC image. It contains the base image plus libgcc1 with the dependencies. Python image. It includes the base image and plus Python-based runtime. Java image. It contains a base image and OpenJDK with dependencies. Node.js image. It contains the base image plus Node.js-based runtime. Well, compared to Alpine and Alpaquita with their 5 megabytes in size, some distroless images can't be called small. Okay, but maybe they win in security. Distroless images contain very few Linux components, and so they have a smaller attack surface. But they are not bulletproof. They do contain Linux components, and so they can have nested vulnerabilities. And the problem is that most security scanners don't work with distroless images, so if there are nested vulnerabilities, you won't be able to find that out. It means that distroless are not invincible, and so it is not enough to simply migrate to distroless. A strong DevSecOps policy with reliable vendors, security scanners, software bill of materials, and regular updates is more important than just a small image. Okay, we are done with talking, let's code. Let's use two Hello World demo apps in Go and in Java. First, Go. As you can see, very simple application with just one method. And here's the Docker file. It is better to use multi-stage build. Build the app at the first stage and then transfer it into the distroless image. Okay, let's build the image. Less than 5 megabytes, well, that's quite impressive. Now let's look at Java. Also, very simple one-class Hello World application. And here's the Docker file. We also use multi-stage builds. We build the application in the first stage and then transfer it into the Distroless image provided by Google Container Tools. Okay, let's build the image. 200 megabytes. Well, technically it's still Distroless. Can we do better with Java? Let's try a minimalistic Linux distro. I will use Liberica Runtime Container, which is based on Liberica Lite, optimized for the cloud, and Alpaquita Linux. There are images with the package manager for building the application, and there are also slim images without the package manager. So, at the first stage, we use Liberica Runtime Container with JDK. We are using the muscle-based Alpaquita image, but Alpaquita is also available with glibc. At the second stage, we use a slim image with Liberica JRE and Alpaquita. Okay, let's build the image. 130. Well, that's better. Java is a dynamically compiled language after all. If you really need to use Distroless with Java, you can build statically linked images with GraalVM native image. These images don't require JVM, and so they can be used with the static Distroless images. So, when you should say yes to Distroless? You run statically linked applications characterized by short runs. You don't need a shell, and your app doesn't need anything, well, Linux related. You know how to debug and configure Distroless images. You are fighting for each megabyte in production. In other cases, complications related to using Distroless images outweigh its benefits, so you may want to consider using a lightweight Linux distribution, Alpine or Alpaquita. They are also very small, and so they have a smaller attack surface. They are easy to configure and debug, and they provide an optimal environment for your application. If you don't want to deal with Distroless but still need smaller images and enhanced security, take a look at Alpaquita. It offers continuous updates, security advisory, LTS releases, and optional commercial support with SLA for patches. And no headache with configuration and debugging. If this video was useful to you, don't forget to like it, subscribe, and until next time!